Hello, everyone. Welcome to today's webinar. I'm Kelly McSweeney, contributing editor at CNEN Media, and I'll be moderating today's event. This webinar is titled How to Optimize R&D with a Unified Laboratory Informatics Solution, and is being sponsored by Uncountable. CNEN works with sponsors to identify topics that are of interest and value to CNEN's audience and consistent with CNEN's mission to provide news and analysis of the chemistry enterprise in a timely, accurate, and balanced fashion. During the webinar, you can adjust the size of the slides on your screen by grabbing the lower right corner with your mouse. If you need technical assistance, please look at the help widget at the top right corner of your screen or type your query into the Q&A box. If you are disconnected during the webcast, please log in again according to the instructions you received earlier. You're encouraged to contribute to the success of this webinar by asking questions at any time during the presentation through the Q&A box on your screen. The questions will be answered at the end of the presentation, and as your moderator, I will be posing as many as time permits. Please note that CNEN does not endorse any company, products, or services that may be mentioned in the webinars, and that each webinar will be archived at CNN Online after the live webcast. The presentation today is being sponsored by Uncountable. Uncountable helps the world's largest R&D organizations accelerate innovation. Through an all-in-one data management software platform, Uncountable provides the most comprehensive solution, connecting experimental inputs to outputs, helping scientists centralize, structure, and utilize all laboratory data gathered throughout the organization to help accelerate the development of new products. During the presentation, we will hear from Jason Hirschman. Jason is the CTO and co-founder at Uncountable, where he leads the engineering team and product development. He was previously at Stanford University, receiving a master's in computer science and a BS in mathematics. He was selected for the Stanford AI Innovation Group, which sought to apply machine learning in impactful ways. Jason's prior industry experience includes building software at Palantir to model data from Syrian refugee camps, leading the mentorship program at StartX, and working as an engineer at BenchPrep. And I will now hand it over to Jason Hirschman.
Thank you so much. It's a pleasure being here today, and I'm excited to talk a little bit about what it means to have a unified laboratory informatics solution and how data in the lab environment can be better managed and organized. So thank you all for joining us. And I want to walk through a little bit about the problem that we've seen at Uncountable and how all of you can better implement solutions in your labs. Now, I helped found Uncountable about 7 years ago. And for the last 7 years, we've been serving companies across a wide variety of industries that all have one thing in common. They're running a lot of complex experiments, and that data doesn't all live in one place. And so we've been really trying to figure out how we can provide a better solution to make sure that data can be co-located, and that experiments that scientists run one day will be useful to them a year later or useful to their colleagues next door. So I'm going to start by talking a little bit about the solutions that are in place today, what it means to have structured versus unstructured data, and then how data can better flow in the lab to get the types of kind of benefits and solutions that we're looking for here today. At Uncountable, we work with over 90 plus companies and deliver a one-of-a-kind platform that users can log into to store their data. Our goal is to provide software that scientists can log into when they enter work in the morning and log out of when they leave work in the afternoon, and be the place and the kind of hub for all communication in the lab environment. And we think we can do this because we've been watching how R&D teams work across a wide variety of industries and trying to learn the types of common problems scientists are facing. We're one of the first enterprise platforms in this space where we typically work with very large companies to make sure that their data environments are things that can continue to expand over time and that we can really focus on data quality and utilization. Here's a list of some of our customers that we can share publicly, but we have, of course, more available on our website, as well as a QR code here to be able to go and look at some of our case studies. What I want you to take away from this slide, though, is that we've seen a wide variety of different problems. Everything from inks and coatings to consumer products like shampoos and sunscreens. And what we've seen in all these different labs is the need to try to unify the environment and make sure teams working in Europe, America, and Asia Pacific are all able to access each other's data, and everyone can read the experiment data that another scientist is putting out. So in the R&D world right now, we have a bunch of different tools at play. We have spreadsheets as the core driver of a lot of data storage. We even have some ELNs or just kind of physical lab journals that are the records of what's happening in an individual experiment. We often have LIMS systems, lab information management systems, that record what's happening in the lab overall, what requests are being made, what experiments are being run that day, and then more tools to be able to work with that data. Visualizations, statistical tools like JUMP or Minitab, and even some predictive tools in some cases. And the problem today is that this data is being spread across all these different systems. So it's really hard to make sure that there's a consistent view of what's happening, and that there's kind of a ground truth to the experiment itself. The way we think about this process is that you have a kind of continuum from raw materials to product properties, and where experiments live somewhere in the middle. There's sort of this kind of upstream set of inputs that you're taking as a lab, things you're getting from your suppliers. What are the prices of the materials? What are kind of the chemical and physical attributes of the things that you're using at the lab bench? And then you're going and actually processing them, and then recording observations and measurements based on that then go downstream to some other teams. And right now, each of these different parts of the process tend to live in different places. Each team might have a different system that they really like. And the problem with this is that it's very hard to do any sort of good analysis. If I want to say predict product properties like customer feedback, or a large exposure testing run from raw material properties, I have no way of doing that without just copying and pasting a bunch of tables together. And so we want to make sure that companies are better prepared to do this type of analysis, are better prepared to take advantage of new analysis techniques, and have all this information in one place. Now, a key distinction that we try to make is between unstructured and structured data. And the reason we think this is really important is that we want to go beyond simply data retention to data utilization. Now, what do I mean by that? Oftentimes when we'll talk to company executives, we'll hear that the #1 goal is 100% data retention. If I collect a data point, that data point will forever live in my company. The problem is that if I never use that data point, all the effort I went into to collect it and retain it, it kind of goes out the window. What we care about at Uncountable, and what we're trying to research and continue to provide better solutions for, is data utilization. If I collect and store a data point today, how many times do I find that data point to be useful later on? How many different future experiments are based on analysis of that data point? And we believe this is only really possible, increasing utilization, if you can focus on structured data. Now, to contrast unstructured and structured data, I'll give an example of a lab notebook. Lab notebooks are great for telling the story of what's happening in the experiment. But if you ever read a scientist's lab notebook, it's oftentimes full of shorthand and abbreviations that make sense to that one scientist at one period of time. Oftentimes we'll ask a scientist to kind of interpret for us notes that they made either in a lab notebook or even in an Excel spreadsheet, a year into the past, and they will tell us, hey, I don't actually remember the exact lab conditions I ran this experiment under, or I don't exactly remember all the different ways that I actually made this measurement. And that can be a really big problem. And so we want to make sure that there's more structure to the experiment data, so that it's less of a story and more of a data point in a database. So on the structured side, it turns out that LIMS systems are actually a better example of this. They tend to be a little bit more structured. They tend to have fields that you're entering into, but they might not capture the same level of experiment detail as the ELN. And so there's sort of a contrast here between trying to capture the full story, but doing so in a way that leads to utilization. And this is the sort of dichotomy that we're looking to bridge here. We want to make sure that we can get all of the benefits of the unstructured data. Things like being able to record very specific details, making sure that you can understand the full story of the experiment. Why was an experiment run? The motivation, along with the benefits of a structured data set. Can you search it really, really fast? Can you make sure that every point is treated like a point in a database? And can you manage all these different systems? We talked a little bit about LIMS and ELNs already, but as a recap, LIMS deal a lot with what's happening currently in the lab. I like to think of LIMS as the present. If I want to understand what's happening today in the laboratory or what's going to happen tomorrow, I go look at the LIMS system and understand what technicians are doing, what tests are being run, that type of thing. ELNs are like the past. They tell you a historical record of what a scientist has done. And there's no real position here where you can look for the future. And so one of the things we think about Uncountable is, if LIMS are the present and ELNs are the past, how do we provide the future? And what I want to talk about today with regards to a unified lab data system is, how can you all build the future in your lab? How can you all make sure that when you're looking at planning a new experiment, you have data that's useful to you and you can take advantage of the things that you're already storing? And the last kind of abbreviation to talk about is an ERP. Oftentimes, the most important system in an enterprise environment is the ERP system. This is very commonly provided by a company like SAP, where you're looking at sort of all the different pieces of information that make up the kind of production and sales processes of your company. ERPs tend not to have the best support for storing experiment data. So they tend to gloss over some of the important details about, why was an experiment run? Where did this kind of production experiment or formulation come from? And maybe don't even include experiment data at all. We'll also talk with companies that maybe have things like analytical data in ERP, like special table, but none of their kind of wet lab experiments. So while it's a really important system, it's far behind in terms of benefiting the lab environment. ELNs in particular are where a lot of people sort of get confused, because kind of look at an ELN and say, my scientist is recording all of these details, I'm retaining everything, and yet I still haven't made progress in terms of data standardization and structure. And oftentimes, one problem with this that I want to highlight is the connection to outputs. So that's this middle data bullet point over here in red. And the idea here is that ELNs are often great at recording what you did in the experiment, but then you often will record results or outputs somewhere else. Maybe you have a different database that stores your analytical results. Maybe you have technicians giving you back PDFs from the analytical lab of all the results of your data, but then those numbers don't actually end up connected with the ELN. And so you need everything to be standardized and unified before you can actually do analysis or before you can actually use this data in a practical way. LIMS often have different types of drawbacks. LIMS are pretty good at connecting to lab instruments. They're the present of the lab, right? They're able to say, hey, this is what's happening today. This is the data that I'm collecting. But they oftentimes don't tell the full story. And one of the problems with a lot of LIMS systems is that they're not analysis tools. They're not meant to help you standardize your data or provide enough detail in the data. And so you still need an ELN or another system to make sure that everything can be kind of put together like pieces of a puzzle. So as a result of having all these different systems, is you end up with different silos. You have some teams that are great at using the LIMS system, other teams that are great at using some other system. You have an analytical team that exclusively communicates over PowerPoints and PDFs, and everything becomes very inaccessible and fragmented. And what we want to do is make sure that our companies, our customers that we work with, have a much better vision of the future here. They can actually unify everything that's happening in the lab environment. And I want to help all of you think about this and some of the core questions as well through this presentation. So what does a unified laboratory informatics platform look like? What does a solution to all of these problems of fragmentation, lack of data utilization look like in practice? The first thing is that it looks like a lot of different things. You have to have a pretty large scope here, because if you miss one piece of the puzzle, one piece of information in the experiment story, then it's very hard to actually utilize the data in any meaningful way. You really do need everything from data acquisition all the way to knowledge management. And along the way, you're looking at connecting actual equipment in the lab. You're looking at making sure that you can manage scientific data sheets, inventory, equipment, everything that's happening in the lab like a LIMS system would, as well as the experiment context that a scientist would provide that traditionally belongs in ELN. So this is an example diagram that we use to try to illustrate what's happening in the lab. And there's a lot of different kind of arrows here, right? Because the lab environment is complicated. But we have kind of three pillars. We have the data acquisition phase, we have the information processing phase, and we have the knowledge management phase. And the idea here is that on the data acquisition side, we need to figure out how we can get information into our unified platform. On the information processing side, we need to understand how we can use that information we have to actually help inform people's day-to-day work in the lab and actually do analysis for today's experiment. And then on the knowledge management side, we need to prepare for the future. We need to do the data analysis, the warehousing to make sure that this data is standardized and useful to you when you want to go and run a new project or a new experiment a year later. Each of these little boxes represents a real part of the lab for some of our customers. On the data acquisition side, you're dealing with laboratory instruments, automation. We're seeing a lot of companies try to build fully autonomous lab environments. You're dealing with a piece of equipment, and then that's flowing through into the information processing step. So oftentimes the equipment will spit out, a structured CSV, sometimes a series of images, and you need to ingest that. Sometimes that gets ingested through a chromatography system, a more complex, specialized piece of software. Other times it goes straight into a LIMS system that's more generic. But it's really important that you combine that with the knowledge management side, where on the far right, we have the ELN, which oftentimes contains the context of the experiment, how it was run. Now, some of these boxes here are highlighted with a darker outline. These darker outlines represent the things that a unified data informatics platform should be able to handle for you. So you're not looking for a really powerful data mining tool. You're not looking to necessarily replace your chromatography system. But what you are looking to do is cut a large slice through the center of this diagram and make sure you have one system that can handle kind of the full stack of what's happening in the lab. Everything from interfacing with the equipment to the experiment context that's provided by the scientists and traditionally stored in the ELN. So the true value prop here is making sure that you can have this integrated solution that really facilitates collaboration and data sharing in a new and innovative way. Right now, it's very typical that scientists only share things through spreadsheets and PowerPoint presentations. This is happening at state-of-the-art industry labs. It's happening in our world's finest academic institutions. If you talk with a scientist about how they shared their last kind of experiment result, oftentimes they'll tell you they did it via a static PowerPoint slide. And this can work for a small research team, but when you have a team of 200 plus scientists, you need some sort of way that they can collaborate and that you can maintain the knowledge that they're collecting without having someone speak over a series of slides. And so you really want to make sure that you're working with a collaborative environment that over time gets better at having a very standards-based piece of data management. Now, if you try to do this all and have one big system that takes over a lot of those boxes in that diagram that I showed, but don't focus on structuring data, you will lose out in a number of key areas. The first is the volume of data. So if you have a unstructured data platform, a platform that maybe prioritizes a historical record of an ELN, it's very hard for you to go and actually do analysis. At Uncountable, what we tell people is we don't have to sell you on artificial intelligence or machine learning, everyone knows that these tools are the tools of the future for data analysis. They automate a lot of what was a manual process. What we have to sell you on is that the best way of actually improving your organization's capabilities in these more advanced disciplines is by creating better, cleaner data sets. And having a larger set of structured data is the best way to do that. That's the payoff at the end of the day. The second is that it's very hard to create Excel sheets that are relevant for more than one problem. We'll often see teams have really, really large formatted Excel sheets that they've been working on for years that try to encapsulate a bunch of different things. Maybe they're trying to do a cell passaging flow. Maybe they're trying to do carbon life cycle analysis. And it's really, really hard to make sure that this all fits together in a reasonable way. It's very hard to do that without a better structured data system. A last thing is that we want to actually solve parts of the scientific reproducibility problem. If you tell a scientist to go and try to rerun an experiment they ran 5 years ago and try to get the same results, they'll oftentimes tell you that too much has changed in the process. And the truth is that they're probably right that a lot has changed. But what's kind of wrong about that is that they shouldn't be able to go change things back. They should have the data available to them to understand what's changed in their process and correct for those changes. So where Uncountable fits in to all these different problems is we want to sit in the center of kind of the traditional types of systems that might exist in a lab environment. There's the ERP system that's managing a lot of the rest of the organization. There's process historians, which are kind of the live view of what's happening with equipment, with a bioreactor, stuff like that. And then there's sort of the regulatory environment. Maybe you have a regulatory team approving safety data sheets or approving experiments to go into production. And you want your kind of structured data system to sit in the middle of all of this, be able to take in inputs from every place of the process. Now, this all sounds great, but in truth is not super easy to implement. And the reason why is that going from unstructured to structured data is very, very challenging. I think of it, as really trying to tame entropy, right? You have these spreadsheets that have been floating around pretty much unconstrained, and everyone's doing a slightly different thing. And so the natural order of things is for things to get more and more chaotic. And to try to kind of roll that back and try to get everyone on the same page to put together a structured data system is very, very hard. You need to be able to identify all the different data formats, who's in charge of what, who's been trying to build the right standards so far, and then try to migrate a bunch of data. How we handle this at Uncountable is by making sure that teams are equipped with kind of best-in-class tools to make this possible. We build tools to migrate data. We also have processes in place to coach teams on how to better standardize. We have many templates that are used to try to get teams on the same page. One of the hardest things that we do as a company is take a team that might be in Europe and a team that might be in America and say, you guys have been running parallel experiments, essentially, the last 30 years. We now want you to run things in the same way, or at least record things in a way that the other team can understand it. How can we go and make that possible? This is very, very hard. And working with a third party like Uncountable or another company is a great way of making sure that you are doing the right thing here and that you have external support to try to get all of your scientists and management team in line to make sure that the silos are broken down. A second challenge is making sure you can integrate with other tools and systems. Oftentimes this means getting the IT organization involved and other parts of your company involved to make sure that everything is working together very smoothly. You often want to connect with an ERP to pull raw material prices or other regulatory information. And there's often kind of home-built systems that need to be replaced along the way as well. This involves a lot of planning, a lot of understanding of which systems are sort of mission critical, which systems you might be able to integrate or ingest data from later, and what's the current data quality of systems. Data quality is not a binary thing. You don't have good data or bad data. Data gets better over time, the more effort that you put into it. And so what you really want to do is understand which of your tools will help you get better data over time, and which of the tools you should essentially say goodbye to in the effort of trying to figure out how you can get better data independent of it. There's also a lot of kind of maintenance work that has to get done, especially if you're trying to do a unified platform with your own system, with your own internal build. You're going to run into a lot of data architecture questions, a lot of bugs and issues, and try to basically have to implement things using your own internal resources. And that can be really, really challenging. The more you can offload this to a third party to deal with maintenance, to deal with requests for new features, requests for new ways of dealing with data, the better off you're going to be. One of the core challenges that any system is going to have, including us at Uncountable, is you're trying to convince scientists to change the way that they're working. Oftentimes we'll have scientists that have been working with Excel spreadsheets for 4 decades. To try to get them to move to a database-like system where things are structured and all in one place is really, really hard. And you need to give them the right incentive to do so. So what you basically have to do is pair sort of the challenge of adapting to a new workflow with a bunch of benefits that they can see to make their life easier. Oftentimes these benefits come in the form of analysis tools, visualizations, but also speed and communication. Can you actually request things from the lab faster if your data is already in a common system? But you do have to recognize that it will make things harder in the short term to actually enter data in because they're not able to do things in a free-form way anymore. And so really trying to build these integrations to support having more in one place, more pre-built for your scientists, the easier it'll make it happen. And lastly, there's a lot of concerns about data security and IT fit. You need to make sure that you understand where your data is being stored and how you can audit changes to it and control it. Oftentimes we'll get questions about things like FDA audits or compliance with ELN standards. And you want to make sure that you're choosing a system that has thought through implications here, because oftentimes there's a trade-off between what you can provide on the analysis side and what's possible or valid from a compliance side. Handling this all internally can be a very, very big challenge. You don't want to have to decide between speed and compliance, between a scientist being happy and compliance. You want a system that can kind of solve both of these things for you. Now, once you've overcome all of these different objections and hurdles, you still have to deal with the process of actually changing things. And so change management itself can be its own challenge of making sure that you're able to actually go and execute on a lot of these changes that you're proposing and making sure that there's a clear transition path from the world of spreadsheets to a more structured data system. And a lot of this comes from building trust over time, of trying to find certain scientists that can serve as power users or people that can sort of create a new workflow for their teammates to work in that can evangelize a new way of working. One of the things we really focus on at Uncountable is finding communication pathways in the lab. We've seen companies where a majority of the communication between an analytical lab and a scientist happens over email. Email is great, it's fast, but it provides a lack of record keeping because it really only lives in kind of the context of the two people that are communicating. So oftentimes what we're doing first is identifying 1 or 2 different communication flows within the lab environment that we could go and try to kind of push into our software and make sure that either end of the communication is happy with the change. I think the last point on the slide is really, really important, which is getting buy-in or kind of executing on change management does not mean necessarily getting full adoption right away. Lab environments are complex. Everyone has a slightly different kind of slice of the problem. And it's really important to let your organization adapt over time, but keep getting better. You want to make sure that you can kind of look at yourself in the mirror and say, our data got better today. The quality of our data today is better than it was a month ago, is better than it was 6 months ago. And it's really important to do this incrementally and make sure you're just continuing to push forward the new workflows and processes that will make structured data in a unified system possible for your organization. Now, for Uncountable in particular, we have an all-in-one solution that really does serve as the center of a lot of lab environments. So we think of us as being kind of the center of a bunch of different systems that already exist and a bunch of different ways of looking at data. At its core, Uncountable is a structured recipe and property database. What that means is that instead of thinking of an experiment as a kind of chronological record book or kind of a log in a record book, we think of it as a data point in a database. And what that allows us to do is start from the premise that this experiment is going to be used for analysis in the future, rather than trying to adapt it for analysis later. We'll talk with companies that have spent a lot of effort to construct databases around one part of the lab environment. Maybe hooking up a couple of different pieces of equipment, maybe having a great process historian for their kind of equipment data. But then they'll sort of forget that they need to take in the context of the scientists and structure why the experiment was run in the first place. From a machine learning perspective, this is like focusing on all of the outputs without having any of the predictors or inputs to deal with. And this does not lead to very good results or knowledge management in the future. You really need a system that can take in all these different sources and make sure that you can unify things if you're going to want to be able to do analysis or make sure you're pushing forward the way that you're thinking about your data. So on the left side, we have what the lab environment typically looks like without Uncountable. You typically have a scientist that's recording notes and reports into an ELN. Now a lot of companies have data lakes where they're feeding in equipment data, maybe analytical data and sensors. And then that data lake often feeds into the ELN. And this can work great for data retention. Everything ends up either in the ELN or the data lake. You have everything, you're sort of happy because you can see the amount of data that you're storing increase over time. But if you go and ask a scientist what has changed with the presence of this data lake or a more kind of electronic environment, they're going to tell you, well, now I type things instead of writing them. And they're not going to have the types of insights that you want them to have with additional data in place. With Uncountable, we focus on replacing this diagram with one that really prioritizes high quality structured data. So rather than simply having data be retained through the system, we want to make sure that it's structured and connected with different sources. So Uncountable sits in the middle. Oftentimes we'll take in data from the data lake and even export it out back some data as well. But the most important leg of this diagram is the one coming from the scientists, where the scientist isn't just entering in notes and reports of what happened or attaching Excel spreadsheets. They're actually entering in structured experiment details, the conditions of the experiment, the parameters, the procedures, and being able to make sure that they have things that provide a structured record for all of their colleagues to be able to understand or for themselves to understand later in the future. The core of this diagram then really feeds around structured data. And that's what becomes very, very important here. And you don't necessarily need to replace your ELN to make this all happen. We'll oftentimes export back out notes and reports to an ELN, but the structured data sort of remains. Now, sometimes we'll get asked questions of, well, can we just ingest data from ELN? And the answer there is, it's very hard to go from unstructured data to structured data. When we go and work with a company that might be reticent about building this type of unified platform. Oftentimes what we'll tell them is the only thing you really need to replace is that first time that someone enters information into a computer. So don't take your physical lab notebooks away from scientists. You don't even take their ELNs away from them. Just make sure that instead of entering a number into a spreadsheet, they enter it into Uncountable first. If every number they enter first gets entered into one unified system, and then they can go and export out to an ELN or their preferred data analysis tool, you're in business because you've started from a place of structure. It is very, very hard to go from unstructured data to structured data, but very, very easy to do the reverse. And so we want to make Uncountable the first place that a scientist thinks to enter data. Now, the long-term impacts we observe here in practice are first that you capture a lot more expertise. There's a problem today where scientists will leave a company and a lot of the knowledge and information that they've gained kind of walks out the door with them. We've heard from junior scientists that kind of working in some of these domains feels like trying to apply black magic, that the idea that they can go and actually formulate a product or advance a new innovation is something that they really need 10 years of experience for. We think this is not true. We think this is because knowledge is locked away today, that expertise is really in kind of the minds of an experienced scientist and not in any one system. By building a unified laboratory data informatics platform, you can make sure that the expertise your scientists are developing are things that the company can continue to own and take advantage of. The second is you can reduce sort of the time that scientists spend manually moving around data. At the end of the day, science is not entering numbers into a spreadsheet. Scientist is thinking about experiments, it's making hypotheses, and trying to draw conclusions from data. The more that you can try to reduce the time that's happening sort of in transit or in process, the better. And that includes communicating with other teams. If you can make it really easy to collect, to actually request testing resources or to interface with that autonomous lab that you're trying to build, you can actually save scientists time and make sure that they're better equipped to do the thing that they do well, which is plan experiments and go and try to generate insights. And lastly, the ultimate impact here is making sure that you and your company can deliver products to the market. We want to make sure that you can adapt to that new supply chain change much, much faster, and that you can use fewer resources for each new R&D win. In practice, we see a 25% plus increase in throughput from the R&D environment with the same resources if everyone's working in a unified data system. So that's it for the presentation today. I'd now like to take questions and be able to answer some of the things that you guys are curious about.
Great. Thank you, Jason, for that excellent presentation. And as a reminder to everyone, you can continue to ask questions through the Q&A box on your screen. We do have some questions. The first question is, could you tell us a bit more about your biggest customers and how Uncountable has helped them? And are there specific industries that Uncountable's platform works better with or others that it's not so compatible with?
Yeah, absolutely. I think it's really important to recognize that an enterprise environment where you have hundreds of scientists looks very different than a small research lab. A small research lab with 3 to 5 scientists is going to have very, very different concerns. We oftentimes will talk with companies that have 10 people total in their organization and tell them, look, if Google Sheets is working for you today as your unified data system, go for it, keep it going. But call us when you get to 30 plus people or 30 plus scientists and it's no longer working. Because at the end of the day, the more scientists you have, the larger the company is, the bigger these problems become. And the more siloed a lot of the resources you're using in the lab start to feel. So for our largest implementations with a company like Sika that's multinational or Beiersdorf, we're looking at trying to connect information from teams that have basically never worked together in the past because they weren't able to. They all had their separate spreadsheets, all their separate systems. And so we're making sure that there is sort of those communication channels that are open and some data standardization that's happening that really can unlock insights from across their company. It can lead to a lot more efficient use of R&D resources and less duplication of work across the whole organization. Oftentimes, this means going and attempting to onboard, 1,000 different users across a multinational organization. We oftentimes will propose, a 3 to 5 year plan to go and make sure that that's all possible, to make sure that we're effectively training everyone to use Uncountable, and that over time they're getting better and better data quality. The types of industries that work well here, anywhere that you're really being measured on the pace of product development. For most companies, the key to their growth is innovating quickly in the market. And to do that, you need an R&D team that can respond to changes in the supply chain really fast, and that can really take a lot of what they've learned over time and put it into practice. And we find that that's a fairly generic request, that most industries have this problem. And that's how we can work with a company like Carbon that's making 3D printers at the same time as we're working with 6+ battery companies.
Great. The next question is, how do you address the problem that these types of systems tend to place so much overhead on a scientist running an experiment? So the scientist tends to run fewer or less innovative experiments, opting instead for autopilot experiments that are already programmed into the system.
Yeah, I think that's a great question. What we see in practice is that there's definitely friction introduced in trying to restrict the way that a scientist is entering data. But oftentimes that friction is a result of them not properly structuring or creating a reproducible process in the first place. So after working with a company for, let's say, a year, oftentimes we'll actually get the opposite feedback. We'll be told that their experiments can be more innovative because a lot of the details are taken care of. They have more confidence that they can go and actually reproduce an experiment that they're running, and that they can have more variations in the types of experiments. Uncountable is definitely not the best system for the kind of the research side of R&D. If you're going and running a new experiment every day that looks very different from the one that your colleague is running, very different from the one you ran the day before, it's not as useful for you to make use of that data. But if you're doing iterative product development, or you have a bunch of scientists working on a very similar problem, then it's almost critical at that point to make sure you have a unified system. And that's what's really, really important here. We often see companies make the mistake of sort of trusting their scientists that what they're doing is super special. If you ask the scientists whether they can kind of combine data sets with the scientists next door, they might tell you, no, what I'm doing is very, very different. But if you take the time to actually look at the data and look at the experiments that are being run, that's oftentimes not true. And especially if you're willing to kind of do a multi-year implementation of these systems, eventually you see most of the examples. You get prototypes of each of the different experiments that are being run. But it takes time. For a typical larger customer, we might build 30 connections, 30+ connections to different pieces of equipment that are getting data. And so if you thought of each equipment as sort of this one-off thing that never recurred, it wouldn't be worth it. But the reality is that your lab doesn't have 1,000 pieces of equipment. It might have 100, but it doesn't have 1,000. And so it's very manageable to, over time, build a better and better data environment and make sure you're taking as good of use of that data as possible.
The next question isn't really a question, but a comment. Someone wrote that the underlying importance of having a system is traceability for compliance and IP claims on your innovation. So I don't know if you want to speak to that at all, Jason.
Yeah, I'm glad someone brought this up because we see this as one of the reasons why data management is a little bit farther behind today. We see this particularly in industries like biopharma, where compliance is a really, really big concern. There's sort of this thought process that having good data analysis and having a compliance is somewhat mutually exclusive. You can choose a system that's good at one but not both. And moreover, that the value of the data is in its historical record for auditing purposes and not for the future. Oftentimes we'll talk with even executives at companies. They'll tell us, look, like the only reason I'm keeping around my data is because I know the FDA is going to come knocking on my door and ask me for it. I actually don't need or want to use it for any other purpose. We think that the number of times we're going to get that answer is going to be reduced over time. As people start to realize the importance of actually making use of this data, of being able to use tools like machine learning and artificial intelligence to actually learn from data, they're going to look at the last 30 years of simply recording data only for compliance or auditing purpose and say, well, we wasted an opportunity. We had the opportunity to structure this data, but now that scientist that collected this data point has left. I don't know or remember exactly the details of this experiment, and it's just too much work to get everything together. We think that the right approach companies should be taking is, yes, collecting data for compliance purposes, but making sure that the quality of that data continues to get better over time, and utility of it for future experiments is not ignored in any way. And so we think there's the opportunity to solve both problems and to really shift the perspective away from, oh, this data is only useful for compliance purposes, to this data is the key to my innovation. This data is the key to making sure that my R&D team is more productive a year from now than they are today.
How is data quality measured?
Yeah, data quality definitely is hard to measure quantitatively. You know it when you see it. Measure of data quality is this kind of data utilization concept that I've been talking about. The idea here is that if you go and ask a scientist how often they're using data they collected a year ago, if they can tell you, I do it every day or I do it every week, you're in really, really good shape. Because oftentimes we'll talk with scientists, they'll say, I've never used data I collected a year ago, or that data is only for compliance purposes, right? So data quality to me means how often are you utilizing an old data point? There's a concept in a lot of pieces of software, including like a social network, of the lifetime value of a user. You get a user to log on to Facebook. How much money are they generating over the lifetime that they use the product? I like to think about the lifetime value of a data point. If a scientist is investing 3 hours of their day today to go run an experiment, that's costing the organization a certain amount of money. How do we increase the value that this organization is getting from collecting that data point so that the ROI there is as large as possible? And the trick that a company like Facebook or Meta has figured out that scientists are slower to figure out is that you have to increase the time horizon. There's only so much value you can get today and tomorrow, but if you can get a little bit of value every day for the next 3 years, or all of your colleagues can get value from that data point, then you've kind of multiplicatively increased the value or the lifetime value of a data point, of an experiment that you're running, and multiplicatively increase the ROI of that experiment as well. And so the more you can answer the question, or the better your answer to the question of, did you use a data point from a year ago is, the better you're doing in terms of data quality, and the larger the lifetime value of every investment you're making into the R&D infrastructure will be.
The next question is, how does AI and ML work in Uncountable's platform? Do the machine learning tools come with the platform, or do they need to be purchased and integrated separately?
Yeah, so my background's in artificial intelligence machine learning. I studied ML at Stanford. Our CEO studied machine learning at MIT. That's really our bread and butter. But what we've learned over time is that ML is easy when you have the right data set. And getting the right data together and structured is actually the hard and interesting problem here. And we tell companies that the payoff to using a system like Uncountable is that machine learning becomes easy and intuitive. And we make that possible in our system by making sure it's basically a 3-click process to get a model trained. 1 click to choose the type of model, another click to choose sort of the spec that you want to run on it, and then 1 click to actually go and execute. And we make good on that, and we'll demo that for you as part of our initial product demos. But at the end of the day, we also don't care whether you're using the ML tools in Uncountable or the ML tools that Microsoft is providing or Amazon, because the ML is really not the hard part. What really matters here is making sure that your data gets better over time. We used to help companies by kind of applying machine learning to help them actually figure out what next experiments to run. And what we realized was that if you look at each project as an independent, isolated project, you never get better at doing them. Your scientists are always sort of starting from scratch at the beginning of the project. But if you look at them as sort of data points in a larger unified data environment, then you can get better. You can build models on multiple projects across multiple scientists. And that makes a really, really big difference, regardless of which models or machine learning tools you're running.
The next question is, how is Uncountable different to Ganymede? I don't know if I'm pronouncing that right. Both systems seem to be nearly identical.
Yeah, that's a great question. So I think that the first thing is that we want to really focus on the UI to make it easy for scientists to enter data. The type of data that we're dealing with is oftentimes not obvious to a scientist before they start entering data. And so we're not dealing with just connecting to pieces of equipment. We're also dealing with the type of data that would go into a manually drawn data table in a lab notebook and trying to connect those sources together. A data management system like Ganymede sort of pretends like the most important data is the data that's automated, that's sort of automatically collected from a piece of equipment. And the truth is that that's not necessarily the most important, that's just the most accessible. And if you have a coding background, it's the data that you end up using. But the context for what's happening in the experiment process, giving scientists the opportunity to explain why they ran an experiment, more information about the sort of setup that they did, the parameters, all of that, that's equally, if not more important, and the stuff that's harder to collect. So Ganymede does a great job on a lot of the kind of automated pipelines, but at Uncountable, we're really focusing on the bigger picture of the experiment context and interfacing directly with scientists as well.
We've got a couple of questions about how to implement a solution like Uncountable. So how long does it typically take to implement? And can you tell us a little bit more about the process of implementing a solution like that?
Yeah, we'd like to move fast as a company. So we've had companies come to us and say, we want a system up and running this year. Can you make it happen? Well, Lesaff is a great example. Lesaff is France's largest yeast producer. They came to us and said, we have this great new state-of-the-art bioreactor facility where we're going to go run all our fermentation experiments. We want a unified data platform up and running as fast as you can make it happen. They set really aggressive timelines. They said, we want every new team onboarded, or a new team onboarded basically every couple of months. And we've had a great time working with them. They've been a fantastic partner to us as a result. And then we have companies that simply aren't ready for that pace. They need to get a bunch of buy-in from executives or different members of their teams, and that's okay as well. So it really, really depends. If you want to hit the ground running and be really aggressive, you can get a lot done in 6 months to a year. If your organization's a little bit more conservative, it could definitely take 2 to 3 years before you have a majority of scientists using a product. But it's definitely a worthwhile process, even if there's a lot of challenges along the way. And one of the things that we want to do in Uncountable is not sugarcoat anything. We want to make it very clear that you will face change management challenges, that you will face pushback from scientists who don't want to change what they're doing. But at the end of the day, this data is just too valuable to let it be locked away in spreadsheets for this long. And we want to make sure that there's a bigger and broader solution here that can unify the different pieces of the lab data environment. So I really appreciate the questions and for you all taking the time to watch this presentation. Feel free to reach out to me individually at jason@uncountable.com if you have any questions for me personally. Otherwise, we have more information on our website as well, along with some case studies that you should check out that talk a little bit more about particular cases that we've had with customers.
All right. Thank you again, Jason Hirschman, for your fascinating presentation, and thank you, participants, for being a great audience. Be sure to check CNEN or CNEN Online for information on the next edition of CNEN webinars. Thank you, On24, for technology and production services, and thank you, Uncountable, for the sponsorship that made this interactive webcast possible. For CNEN webinars, I'm Kelly McSweeney. Goodbye.